Hi everyone, I'm Stefania Soldini from the University of Liverpool, and today I would like to talk about origami solar cell technology for next generation of self-reconfigurable CubeSat. This project was completely in 2020. Um, so, first of all, this is a team from Liverpool. We have Paolo Paletti, my co-I, and Aloisia Russo, which has worked on the project. And then we have collaboration with Oxford Science System, JAXA, but also it has been a unique opportunity for us to collaborate with the University of Glasgow. So let me give you an overview of the project. So solar sail are thin film material. It has been tested by the ICARO missions, and they are basically a different way of propelling a spacecraft. So without using any fuel, so by just reflecting the sun radiation, we are able to actually move in space, like sailing. So that therefore solar sailing. So these are like Kapton material aluminized, and is used with this concept for either pushing the spacecraft or for attitude orientation control. So for orientation control, what usually been done is to use reflective control devices. So changing the optical property on the same material is possible to exercise different forces on the same material, which allow rotations. So starting with this idea, the fact that solar radiation pressure could potentially be modulated, so the effect of the intensity of the solar radiation could be modulated in a way which we control the let's say this say reflectivity property, then the idea came into mind to use this concept for controlling actually more complex folding. So what we aim to do is implement what we call origami robotic, and where we have defined actually origami sat. So a satellite that is manufacturing in 2D and can be folded in space, achieving complex shapes. This allows reconfigurability, but also achieving complex um, scenario where like a sail can transform in different things. So this was a proof of concept, and we use additive manufacture for prototyping our idea. So what I mentioned before is we are interested in multi-operational origami sat. So forget about the traditional design of a satellite where we have a large spacecraft with different components mounting different, um, let's say, instruments or antennas, solar panel. We're talking about here of a new idea of origami sat, a new concept of solar sail technology, where we stack, for instance, this compact way sail inside the launcher. We deployed in space using what ROC what we have come up with, and then we, for instance, change shape, for instance, to achieve a shape like this pyramid for a re-entry vehicle on a planet. Now, to do that, then we want to experiment with different deployment idea. Here was really our proof of concept on paper, how we fold and unfold the sail. Traditional approach will include having a mechanism, a boom, is a one-shot set devices or centrifugal spinning forces to achieve that. In the feasibility study, we propose this deployment from launch using shape memory polymer for the 4D material, and I will show you later. And for the reconfiguration, we have each facet, we design it to harness the effect of SRP in a modulated way. So we use actually optical control property for controlling the shape. And this can be a reverse process as well. So this idea is innovative and has never been done before. In Liverpool, we have done the part of manufacturing or actually understanding the mechanism, how to manufacture that. So we have experimented with what we call cartilage pattern, like you see in the left here, or mechanical pattern. So where we have hinges. We find out that the most lightweight effective for the harnessing solar radiation pressure has been using the cartilage pattern. Um, at the University of Liverpool, but specifically in Glasgow, we've done also simulation into uh, how so we can scale up from what we have prototype in space and what are the sizes we need to make sure we can harness the effect of solar radiation pressure. So we come up with a facet which would be an edge of a facet of a meter size. So this is an example of simulation with the effect of solar radiation pressure. Now this is how we manufacture the structure. This is a CAD material. Basically, we don't use um, how can I say we don't use the 4D material everywhere, but actually only in what we call the active, let's say, edges. So the one where we need to exercise a force in order to the deployment. So in this case, are these blue color represent where we are having the active fold. We mean the meaning is that we have the capto material, we print basically the border of the facet, but we don't necessarily need to add material between facet where the folding is passive, which means saving a lot of mass and material. Um, and this is basically the final prototype how it looks like. So the Kapton used is actually qualified for space. It's aluminized Kapton, so you can see the orangey yellow face is the Kapton itself, and the aluminized part is the one that reflects the solar radiation pressure. Then we use the 4D material where is printed here. We apply an external heat force, heating, for instance, for trigger the shape memory, and then we unfold it. This has been a quite successful cooperation with JAXA, Oxford Space System, University of Liverpool, but also a collaboration will with Glasgow, such that we recently have submitted this article, which is under review. Actually, I can tell you we received minor revisions, so fingers crossed you will see this work soon. Thank you for listening.